So my name is Nathan Moffat. I'm going to lead us off into the discussion. For the next two sessions, we're going to risk the wrath of the Tech Field Day gods. We always risk your wrath in general by breaking this section into three pieces. First will be a short preamble over the why for the technology. Second, we'll go through detail on the how, and then we'll actually do a live demo. This is actually going to be coming out of what we call our Center of Excellence. So we do have demo environments across the world that we can pull data from, but anytime you want to show an AI-based technology, we figure it's good to have data on the back end that actually can allow us to show what's being used to build out information, to learn, and to figure out what kind of suggestions we should deliver. So the best centers that we have for that are our Centers of Excellence. And as we go through that, that does mean we are going to go out to a live demo to actually show you how these products work in that piece. We do have backup plans. That is tempting the gods. So we do have backup plans. There's always plan 2, a plan 3 for any disaster. Well, at least for this disaster. But we're hoping it's not going to come to that. So the first product we want to talk about today is Hitachi Infrastructure Analytics Advisor. Comment was made a little bit earlier about big data analytics. What kind of analytics are we going to be talking about? There are three key ways that Hitachi looks at analytics. First, systems to help deploy, accumulate, gather data that can be used for analytic-style operations. We'll be talking about some of that later today. Second, business value data analytics. So if any of you have small kids and you've heard of a company called Spin Masters, they do things like Paw Patrol is actually what it is. There you go, exactly right. I screwed that one up. My nephew will be upset about that. That would be from our Pentaho side. So we won't be covering that today. We'll have to think about that for a future opportunity. Today, though, we're going to be looking at more of the operational efficiency side. What can we do to take data from the systems in the data center and leverage that to help make better decisions about the way resources are managed, the way that resources are used? So when we look at that, there are a key few things we want to go through before we actually go into the how it works section. First off is around our overall approach to how we gather data analytics from the environment itself. Originally, when Hitachi started looking at data center analytics, we took more of a inward-looking view, trying to gather information about our own system so we can make predictions about what was happening with our stuff. But as we were doing that, we recognized very quickly that our customers, especially our bigger customers, said, look, that's great, but trying to analyze a problem, make recommendations in isolation of your own stuff doesn't get the job done. You have to be taking more of a macro, a broader view. And so what drove out of that is a continued effort to make sure that when we're looking at resources, we're looking up and down the stack. Now today, and this will extend over time even beyond these categorical areas, we are looking at, of course, storage, but not just our storage. We're looking at data that we can accumulate and gather from multiple vendors worth of storage. The network, server operating systems, hypervisors as well, because we want to make sure that as we're trying to analyze where something is happening, why something is occurring, we aren't doing it saying, oh, well, look, the storage is running slow. For anybody who's ever been a data center admin and done systems work, you recognize that the problem is always, of course, the server or the storage. It could never be anywhere else. So we wanted to make sure.
The network guys say it's always the network.
It's always the network, right? So, we always want to make sure that we're taking a broader macro view of exactly what's happening in the environment. So as we go through the demo and as we go through some of the how, you'll see how we're taking data from across the entire stack to make predictions, to make recommendations to customers about what's happening. One of the areas that we're going to drill into, and we'll show you some more detail on, is also going to be around how to keep applications running faster. Now, with any kind of analytics tool, well, most any kind of analytics tool, you can do static SLO management. Put a service level objective in place, monitor that. If it's not performing as necessary, you know that your end user is going to be unhappy, you know that your application admins are going to be unhappy, business will slow down. You can put a threshold alert to say there's a problem. And that's great from a business standpoint. But from an operations standpoint as well, you've got two aspects you want to consider. First, no SLO stays static for very long. Much like any battle, as soon as you gauge an enemy, the plan of attack must change. As soon as an application starts to pick up utilization, you need to be making sure that you can adjust that SLO. Secondly, IT staff are not infinite resources. Anybody who's worn a call center pager knows what it feels like to get a call on a false alert, try and go and look at it and say, wow, did I just really waste my time on that? To make sure that your IT staff is happy, and therefore your operations are running as smoothly as possible, we're going to be looking at how we can go and have intelligence within our software, constantly monitoring historical data from application trends, workload trends, to make sure that we are constantly adjusting that SLO level to stay in touch with how the application is behaving over time and make adjustments so that we can make sure that A, we're meeting the requirements of the end users, but B, we're not generating false alerts that might in turn make sure that your IT staff is running around chasing squirrels that don't really exist.
Okay, you know the data on the slide and that story don't jive, right?
Where did we break?
Okay,
Howard.
The third band in the bottom graph, you've got a little peak that, no, next one to the left.
To the left.
You've got a little peak that exceeds your red line there where you've pushed your threshold down.
Right.
That's going to generate a false positive.
So it also depends on how the customer set up damping in the environment. So how many violations are okay per minute or per hour? So you're right. If I look at it in an entirety of a block, it's a violation. But if there is damping turned on, it may be avoided or avoid a false alert.
Howard, it's a graph, though. It's a graph. That's not a real trace. It's a graph.
I understand that, and if you're going to make up data, it should be data that you make up to support your story, not data that you make up that contradicts your story. That's all I'm saying.
I think the other chart that we actually have is the standard deviation.
Yeah, we'll do a real demo.
Yeah,
How about a real demo? That sounds like a good idea.
I'm not criticizing the product, I'm criticizing the slide.
Just keeping him on the
And if I didn't have criticisms of slides, I wouldn't go anywhere. So, thank you.
But also on the data you made up, never reduce your SLOs. Because you now face the problem, and this is the same problem as, why I have QoS that keeps my users from seeing that the storage system isn't busy. Because if they ever see 150 microsecond latency, they're going to demand 150 microsecond latency on busy days too.
Yeah, so then you get into the aspect of who do you actually allow to see that
Exactly.
data?
I think it's
always a key one. So you actually want us to put a feature into the product that actually we can go in there and manually adjust it up so it actually looks worse than it is? Sometimes.
perception.
HP did make that calculator. It was extra weighted just so people would see that it's heavy. They had some health behind it. So.
Yep.
Actually, that's called the ball and chain effect, right? You put a big weight on you to keep you somewhere in place. The other area that we're going to drill into on this, and it starts to get the same, which is why we put it on the same slide, is around accelerating fault resolution and simplifying forecasting. So there are two functions within Hitachi Infrastructure Analytics Advisor that allow us to go and take a look at the environment as a whole and identify for potential optimizations, as well as to identify and resolve problems that may exist. The first is around accelerating fault resolution. This is a place Manu's going to go into a lot of depth into how we actually do end-to-end monitoring to figure out where faults are occurring and what causes it. In conversations with our end users, with customers, and the benefits that they've seen about in this, especially in larger environments, it does give them the ability to find issues up to 2x faster. And that's looking across an entire data path to see where issues might have occurred based on analytics we're gathering, as well as looking at configuration changes that may have occurred in the environment. So taking more of a broad brush view of what might have caused an issue to occur. Second, and we'll go into a lot more detail on this, is resolving issues up to 4x faster. Part of that is based on the idea that we can isolate and determine what caused the issue. Part of that is also a new heuristics engine that we've built into the product and are adding on a daily basis new capabilities around to allow us to say, here's a prescribed outcome that we think you should take to go fix that problem. And as we go into the next section, you'll see that this all touches into Automation Director, because then we can go and actually launch to auto-resolve that event as well. So again, making it a lot easier on the IT staff to eliminate issues which might be impacting business performance, business uptime.
So Nathan, is this capability existent already in the field? And are these find issues 2x faster, resolve issues 4x faster? Is that from field?
So the 2x faster and the 4x faster is based on field data. What's new And so we don't have the full gist of exactly how it's going to ultimately be improving things. Is the heuristic engine did just come into the product recently. So that's not something we have a lot of field data back from beyond some initial beta testing.
But
So,
heuristic engine?
right.
Are you going to talk about that later on?
We will. We will talk about some of the specifics on that and some of the analysis that it can drive out.
Haven't you guys gotten the memo? You're supposed to just say AI, AI, AI
Yeah,
over
exactly.
all of
That's what-
everywhere.
I was going to.
Or machine learning.
I mean, that's what every other company would do. Even if it doesn't have this stuff, they would just call it AI.
One might argue that Hitachi tends to be so conservative that it's to a fault, right? You know, if I take a look at this product over how many years? 4, 5?
Well, went GA 2.5 years ago, but we started developing about 4.
You know, you'd argue that we started with the technology and we talked about the technology, and that's all we did. We never pulled in any of the nomenclature. And then we started to see others in the field come forward with products, and we're like, well, we do that too. But we weren't playing the buzzword bingo game. And we still are reticent to get too buzzword bingo, but we recognize that there are features we need to be more in line with the way the market is talking about them.
Well, in all seriousness, I do appreciate that you're not, going overboard with the AI and that you're focusing on what it really does instead of just pretending that it's some robot from Westworld.
So with that in mind, I'm going to now go into full Westworld mode.
Sweet.
And go after it. And then the final thing I'll touch on here, because I really do want us to get into this, is the idea of predictive analytics. Now, a number of products have had that in there in the past. We had the capabilities, but we hadn't fully productized it yet. So with this functionality, there's 2 ways we're going to look at leveraging predictive analytics. First, from a budgetary forecasting standpoint, and we've seen a lot of interest in this from customers about how do I make sure that I either reduce payments, reduce what I buy, by making sure that I'm going and fixing the right problem. Don't buy a new storage array if that's not really what your problem is, or delaying purchasing cycles. And that's another place where we've seen a lot of benefits from customers as well, where they may see they will need to buy storage in the future, but with a better analysis of how data trending is occurring, where bottlenecks are occurring upstream and downstream, they can make better determinations over exactly when to buy it.
Are you actually able to truly forecast and model performance against future loads, or are you just saying by making the system more efficient?
So we're modeling based on the loads that we've seen and the growth rates that we have seen. Now, one of the things that we can do a little bit of work on, but we're continuing to develop into the product, is the ability to put in what-if analysis. We've got some basic capabilities there today, but we're also advancing that what-if engine as well to allow you to make determinations over what might happen in the environment too. But today, it's primarily based on historical trend analysis, periodic function analysis, things of that nature. So with that in mind, I'm now going to turn it over to the brain of the brain, Manu, to go through some of the functionality.
Thanks, Nathan. So getting into a bit more details, and as Nathan started the conversation, we started the product development about 4 years ago. And part of the understanding was how we evolve the product set as our customers and consumers are evolving itself. One of the challenges we've tried to solve is when we walk into a data center, the biggest challenge is how do you scale the management of the environment? And the other big challenge is how do you translate the tribal knowledge which this one person has to scale itself? So scaling the management part itself, scaling the intelligence around that. Another part is just scaling the tribal knowledge that if this happens, this is what's always been done, this is what you should be doing in that kind of mode itself. So the product was designed with some of those things in mind. And I'm going to cover there are a lot of cool features in it. There'll be 3 main features I'll be highlighting. And then we'll get into the demo of the product itself. But some of the highlights of the product, our goal has been to reduce our mean time to recovery. If you have a downtime, or if you're seeing a problem, how soon can I find out what the problem is and where do I address it? First thing is, where is the problem? What is the problem? And how do I fix it? And so the focus was on mean time to resolution. And when we get into predictive, we start getting into negative MTTRs also, kind of how do I predict a problem statement. Enhancing user experience. I mean, the system has
Negative MTTR?
mean time to repair.
I understand what MTTR is. I'm just I'm having
You can go
difficulty.
back in time.
Oh, negative MTTR.
I'm having difficulty understanding how you fix something before it breaks.
So it's
You
with
can
the
avoid it breaking. That's a different thing.
Minority Report.
Yeah, I'm a character
AI.
in Minority Report.
So it's problem avoidance. Yeah. So with enhanced user experience, as what we wanted to look at was not just the storage environment. So if you look at the product that this product is replacing from a previous gen, it is looking at a much more holistic view of the environment, not just say, hey, I have a storage environment and this is what you can look at, but who are the consumers of the infrastructure? What are their expectations? What does an SLO mean to a consumer of the infrastructure itself? So there's a lot of focus on enhancing the user experience from that perspective. Cost optimization, being able to predict, and working with our automation to say, if I see something, can I do something about it? And what's the gap between seeing and doing? And do I always need a human in the middle? Or there are cases where if I see something, I can do something in an automated fashion to the comfort of the customer itself. The other part of the product design was also to look at what are our target consumer roles that we're looking at. And of course, traditional has been our IT operator. Like I see a SLO violation, I see a high CPU, what do I react to it itself? But more and more, when we walk into a data center, data centers, because of their consumption rates, are an operational challenge and also a logistical challenge. How soon am I consuming my infrastructure? When should I get the next thing ordered so I don't have stuff lying around that I'm not using itself? So getting into the various roles where IT leadership, finance, system operations, being able to provide data and address challenges in those space, that's kind of some of the areas where the product's going after. And of course, we want to look at every metric our storage infrastructure has to do, but how is it consumed in the larger context of network, servers, virtualization, operating systems, and also getting into some of the third-party vendors, also bringing it all together to say, can we provide our customers a single pane of glass for this piece of infrastructure? And of course, the universe that a customer operates in is very diverse, very, very large, and it varies from customer to customer. But for this segment of the infrastructure, can you provide an integrated view of the environment itself? And as I mentioned, like every customer has a variety of information. We can provide them to the nth degree of depth of what all is happening in this piece, but there are still cases where they want us to integrate northbound into other applications. It could be getting it into Splunk, getting data into Pentaho to be able to blend data from a business analytics standpoint. So the system actually has REST API to get any piece of information out of the system itself. So that was some of this background around why the product started, what were the thoughts behind it, how is it evolving over time. And one of the biggest challenges was deployment architecture. We have this deployed at some of the customers that are monitoring 35,000 VMs with this. One of the largest databases of performance data at our customer site is about 9 petabyte. That's just metadata that they're collecting across their environment, across 1,200 storage systems, heterogeneous systems. So the deployment piece was extremely important for us. And getting into AI and ML, one of the biggest challenges is your algorithms can be good, but they are no better than the data that you have. So there was extreme amount of focus on maintaining the quality of data. We got into the spikes discussion, but to the point of that, you can hide anything when you start doing averages. You get into minute level averages, hourly averages, daily averages. To avoid that, we have a modified version of a graph database, and Hitachi actually has patents on this. We're able to store multiple year, 1 minute data across the environment versus averaging it. So if you look at a lot of the products, they start to average after like a day or a week or a month. The way the product's designed, it actually keeps 1 minute averages across the entire set. So if you want to look at what happened last Black Friday and how my system is going to respond next Black Friday so I can prepare for it, you actually have the spikes, not the averages, to make a guess on, am I able to survive that, or where do I need to create space for the environment itself? So from a deployment standpoint, basically you have a server piece, you deploy, and then all the collection is done remotely using remote APIs for the entire environment. So very low footprint in that sense.
So Manu, is this information that or is this processing being done in-house at Hitachi, or is this something that the customer can do with their data locally, or how does this play out?
Sure. So we have 2 deployment models. Given our customer base, a lot of customers prefer everything in-house. especially they don't really want anything going out of data centers. So we have the first deploy model is an on-prem where a customer can deploy everything on-site and it's working locally. We also have a model where the product is running in AWS and it's a cloud deployed model. So both models are available.
And when it's in AWS, is it truly, I like the way you used the word tribal previously, and I presume you mean across the entire installed base. But you are analyzing data across the entire installed base, or sorry, across all those customers within the entire installed base who have opted to send their data in.
No, we don't. So we maintain sanctity of the data by customer. Again, going with our customer base of Fortune 100, they really want silos. So like some of the data where customers can be sensitive around is IP addresses, server names, application names. They really don't want that data to be out and about and shared with any kind of logical differentiation.
So the predictive maintenance that you're doing at these customers' advice through the Hitachi Infrastructure Analytics Advisor is only based on the data within a customer silo?
It is based on the data within the customer silo, but the heuristics are developed based on the larger set of data that we get from customers.
Ray, I'd say there's two things to be aware of, just so you're aware. There's HIAA, which is a broad scope analytics piece. But we also have what's called HITRAC. I don't think we're going to cover it this afternoon. HITRAC is what you might be thinking of from more of a traditional vendor aspect of, let's gather all the heuristics data or all the data that we have over how storage systems have performed across all of our customers. Use that data lake to understand exactly what's going to happen, fine-tune code, fine-tune alerting practices, do predictive maintenance from that side. This is a supplement, if you will, to that actually is going to take a much broader scope view. Now, long term, we merge
from a customer perspective as far as outside of storage, infrastructure, operating systems, that sort of stuff.
Correct.
Yeah.
Correct.
So the heuristics, so you don't aggregate customers' data. It doesn't get thrown into a giant pool and analyzed. But the heuristics are based on an aggregated data, which means that the data must have been thrown into a giant pool.
So we do get, we request our customers to share data every now and then, and our data science teams takes that, validates our algorithms, trains the data sets, and then the algorithms get pushed out as a product itself. So that's kind of what I mean by we do train the data set on the larger data coming from multiple customers, but we don't really have a giant repository where 6 of the customers' data is coming in and the data is cross-pollinated. We maintain data sanctities across customers.
Okay, thanks.
Sure. So getting into a bit more specific feature sets, and the first problem we're trying to resolve is what really is part of the universe that matters to me. Like the universe can be, like some of the customers have 2,300 storage systems going across thousands of VMs. But when you have a problem, the first thing is where is the problem and what is the impact zone? Getting to that point is one of the key and fastest way to do it. So what we have is, and Hitachi also has a patent on this, is we are able to build relationships across elements dynamically, where once you identify a VM, we can identify fabric. If you're spread across 6 storage systems, 6 pools, 24 ports, we can look at, for this particular VM, what really matters and clear the noise. And in that environment, what really is a problem area or a potential problem area itself. So we never show a topology which is of the entire universe, because really that doesn't mean anything. What really starts is where's your impact and what's in that impact zone that could potentially be causing a problem. Are you the cause or the victim? A lot of cases, a lot of the production applications are actually a victim because they're managed well, but test applications are causing the issues itself. So the topology view is designed to quickly identify an impact zone of what really matters to a particular problem set and what really you shouldn't care about in that context itself. Now, the next thing, once we've identified it, the product is encapsulating a lot of tribal knowledge around what are the ways that usually experts solve performance and configuration or any kind of problem issues. So we have algorithms built into the product which go through to say, can I help you identify a bottleneck? Where could be a potential bottleneck? There are two ways. You can read a 1,000-page manual, or you can look at the product and we'll walk through to say, what is the life cycle of my I/O? Where did my I/O get generated? What all did it traverse through? Where all was it serviced? And how did it go back through the layers of virtualization that are in the system itself?
And the root cause analysis is part of the heuristic package.
It's part of the
Just got
heuristics,
rolled
exactly.
out soon this last time. And you mentioned 4x root cause
Time saving.
savings based on your view of what that can do.
So how quickly you can identify a problem, how quickly you can identify cause of the problem, and how quickly can you fix it.
And you mentioned that the dependency mapping is something that's done by the customer, is that?
No, it's completely automated. And so we're using the underlying data warehouse that stores the data, actually builds the relationships across the different discrete data
So you
sets.
have agents in all these systems, or how does that work?
So the data is all collected remotely through remote CLIs or APIs. So essentially you have one probe server and one data warehouse, and the probe server connects to all these things, gets the data at a regular frequency itself. But most of the data collection is pretty much remote.
So do you guys, or one of your solutions from I think the term you guys use are SIBU, bring that all the way through to business outcomes? So high I/O will impact order processing and SAP ECC, which will equate to higher transaction times and loss of X amount of business for this particular product.
So you can get to that, and that's where integration with Pentaho kicks in. So if I look at the parts of the universe this cycle covers, and I'll go back and slide in a second. So we can go from where literally the I/O is serviced with spindle and everything, down through cache parity groups, going through fabric, going through the servers and VMs. And here you've identified which applications are getting impacted. And are those applications gold, silver, or platinum? So you've given them kind of service levels itself in that. So from the universe, you have figured out what are the business applications that will get impacted by this. What you can also do is, because every company's business is diverse, we integrate data into Pentaho where customers can bring in their own business data to say, when this application is hurting, and these are the areas, this is the actual thing that is reported up north, and this is an impact zone to say, well, the ATMs in Chicago were down because this happened. So being able to correlate those pieces of information can be done with integration from the northbound data set.
So the nice thing about this, right, is you can almost treat it like a layer cake, right? HIAA can be your primary interface into everything that's happening, and you probably would as a data center leader, right? You'd want to take a look and see what's going on and understanding what's happening there. But to your point, as you drive up to more business value orientation, we then sit underneath as a data source into the bigger business value dashboard. And we do actually have a large company that's actually doing that with us today, where they take data sources from HIAA plus a number of other locations, combine that up into a graphical view that says exactly what you're talking about. What's the overall impact? How it's going to influence my business outcomes?
Because from a data center manager perspective, it would be nice to be able to say, it's easier for me to go to Tim and say, you know what, Tim, because I have these analytics from Pentaho and this piece, I can tell you that if you give me $150,000 to go buy this new Hitachi HIAA, you will get these business outcomes.
Yeah.
Then Tim is happier if that's the goal.
You're assuming that Tim actually believes what he says.
You know I'm in the room, right?
Tim.
I thought you were
We got a
talking
spare Tim. It's all right.
I'm the other Tim.
I'm the spare man.
You must be talking about you. So can we go back to this for a second? So when you talk about impacting the applications, how do you know? Like what? Give me some perspective. I mean, applications and workloads are very complex beings, and they have relationships across an entire value chain, an application value chain. Are you saying that you are understanding what that impact is to the user of that application across the entire chain?
So we're able to, when we say application, it's the components of infrastructure that application is dependent on. So if you're running an HR system, what hypervisors, what VM systems, what fabric, what storage systems spread across multiple storage arrays, and what components inside storage systems actually impact that application. We're able to build that correlation. But then the application itself, which is the APM zone, APM gets into its own territory to say, okay, if I do a credit card swipe, it goes through 6 different systems. So where we draw the line is, and in some cases we're actually working closely with some of the APM partners to bridge that gap, is we stop at the infrastructure hypervisor layer and we say, this is a container for application X, and we go south from that side.
So just so we're clear here and not just using generalities to convey something that's not true, you are only managing the storage piece and only the infrastructure component of how that might impact. You're making a lot of assumptions about how it might impact an application, but you don't. If you're not managing the actual impact of the application and the user experience, you're not managing the application.
So if I've written and to piggyback on that, Tim, if I've written a poor, I use my ECC example. If I've written a poor query in ECC that's just inefficient, that's going to translate into I/O on the back end that you guys interpret as poor I/O, but that's poor I/O because I've wrote a bad app.
I think they're conflating infrastructure to application.
Yeah.
Yeah.
Agreed.
And in our case, what we define infrastructure is, an application is the aggregation of storage, switches, and compute infrastructure that support that application, and we're calling that as an application container.
So I guess the next question goes to
Containers. That's not what
ultimately the
containers
goal,
look like
which is
anymore.
to find out where the problem is. And I've supported enough enterprise apps to know the frustration that the order to cash team says orders are slow. They call the ERP team that handles the underlying ERP application. The ERP application team says, oh, we're getting slow response from your piece of it. What should happen is that your piece and the APM talk together to find out where the problem is. Like, is it a bad query or is it a actual problem in performance?
Yeah,
right.
Exactly. So this can quickly eliminate to say, is the problem in any of the infrastructure components, or is the problem in an application query or other parts of the application itself?
Sorry, Manu, I know this conversation's going on a bit long, but that does come back to what Ray was talking about. When you said you can identify problems twice as fast and resolve queries 4 times as fast, or maybe it's the other way around. How did you get to those numbers 2 times? I was thinking, is that the number of steps, or did you time people? You actually time people in the field?
So I think in the following slides, I get to specific examples of what are the recommendations that we provide around workload balancing, or what are the recommendations that we provide around what resolutions that can be done, and if those resolutions can be done automatically using our automation engine. So I think as we go through it in the following slides, it gets into specific examples of how basically it shortens that time to repair.
We spend a lot of expensive time figuring out if the problem is within the application or if the problem is within the infrastructure. And count me as a skeptic that you guys are able to shorten that time to finding out where the true problem is with just AI. So that'll be interesting to see.
I think that's the problem identification part. And that's essentially, if you look at this chart, and we can show more in a demo, this can quickly show you these are the infrastructure components that are supporting that application. And if you see a problem over here, there are pieces to drill down. If not, the problem somewhere else, not on the infrastructure side itself. And to support that, there are algorithms that are designed to say, can you verify bottleneck? Can I identify that am I the victim or the cause? So because it's infrastructure is more and more shared, ports, cache, microprocessors, fabric, everything is shared. So looking at to say, well, I'm looking at this problem, but who else is in 1 or 2 degrees of separation? The other biggest piece that we changed across infrastructure elements was to say, usually tools that are trying to solve performance issues are focused on performance itself, and they ignore the configuration change part. And especially in large enterprises, it is, oh, there's a change management system. So the application in this case is actually storing all the configuration changes, and you can go in and say, well, I was getting a 4 millisecond response time yesterday, today I'm getting 10 millisecond response time. A and B, tell me what changed during that hour. Not just from a performance standpoint, but give me a log of all the configuration changes in that time period itself. And our customers find a lot of issues right around that to say, well, I was using this pool and we deployed 2 new volumes out of this pool to this other application, and the problem started over there. It gets into identifying cause and effect, where is the problem caused by a workload change, or is the problem caused by actually maybe an innocent configuration change on a port? Somebody changed the fan in, fan out ratio of those things itself. So it basically correlates configuration and performance together in the analytics tool itself.
So
which kind of configuration are you able to capture? For example, for a virtual machine, you capture the virtual machine configuration. For storage, you can found if something has changed in the number of disks or.
So all of that. So basically, if I'm looking at a storage system, I can look at if somebody allocates a new volume, somebody allocates a volume to a port, so you change the fan in, fan out ratio. Are there any cache modules that were added? Are there more drives that are added to the pool, parity groups? All those changes are tracked within the system itself.
And that's across not just Hitachi gear, but other products as well? Or?
So we're doing a lot more advanced analytics on, so there are 2 parts to it. For VMware Fabric, we're doing the same changes. We do configuration changes. For third-party storage vendors, we're not tracking as in depth. We're doing a lot more advanced analytics for Hitachi than other vendors.
So I'm still struggling with why, as a customer, why would I have my storage vendor be digging into this as opposed to someone higher level in the stack that has a broader visibility? Because as we get to more complex applications
Absolutely.
And the user experience, having someone come from the bottom up, and I probably already have someone that's managing that, whether it's my CMDB vendor or someone who's managing change on a broader scale. Why would I entertain the idea of someone like Hitachi doing this from that bottom-up perspective?
I think where we are finding a lot of traction is around layered analytics. So a lot of higher-level tools do have the higher-level visibility, and they're able to connect the dots. Where they need to deep dive and hand it off to tools like HIAA is where I can have problem identification be done in the higher-level tools. But problem resolution, they don't have the kind of depth of data that is needed for problems resolution. So that's where the tools are working together to tie things. And it is not just they're going to deploy this and not have higher level tools, but it is where is the handoff and where does the customer start? So problem identification, problem resolution, and maintenance.
So I get that. I wish you would have started there.
Okay.
I mean, candidly.
Sure. Absolutely. That's good.
Because it sounds like you're kind of bubbling from the bottom up and trying to do it all. And I'm not buying it. But if you were to convey that as kind of setting the context.
Because the only valid value proposition that a vendor who actually supplies the kit can have is that they can tie deeply into the management of the kit, and therefore they can proactively monitor and manage from that monitoring.
Absolutely.
So start with.
But that's within that. But that's within that context, right?
Yeah.
Further in.
2 thoughts too. I know we want to get to a demo. And there's not a ton of time left, but maybe we are a vendor who happens to also sell storage. We bring the biggest domain expertise there, but I think hopefully over the next few of these conversations, maybe we're not just a storage vendor, right? And that's part of the difference in the conversation with customers.
Okay, I used the word storage, but infrastructure. Still, the same argument still applies.
Okay.
I think it's layered analytics. That's what kind of we are hearing from a lot of our customers. It's they want to build that stack.
Isn't the real question that, what else can I buy?
I don't understand what you're.
Your CMDB vendor has a CMDB. Who else can I buy the inference engine?
Integrated infrastructure and application monitoring.
Yeah,
and I think
that's not the question I'm asking. In fact, enterprises are moving the other direction and trying to reduce the number of vendors, not increase. So I'm not looking for another product to buy. I'm going in the exact opposite direction. I've been doing that for years, which is how do I reduce the number of tools, not increase the number of tools to create greater simplicity? But before I get there, I need to at least have some level of confidence in knowing what are you batting outside your wheelhouse? Are you, I mix metaphors here, but are you kind of going beyond your capability, or are you staying within your capability and maybe just conveying it in a way that I'm not understanding? And I think it was the latter.
Or are you going to announce the acquisition of an APM vendor in the next 6 months that will then deliver what we're asking for?
Or from my perspective, if I'm a data center manager, chances are if I'm looking at this, I already have Splunk. I already have other tools. So from an operations perspective, when I call the Tiger team to troubleshoot the issue, where do I start? And I think the demo might help us understand that, because I have way too many tools, and do I now have yet another tool with conflicting information to extend that outage? So,
and they all kind of promise the same thing.
Yeah,
right.
They all kind of,
I think it's kind of the, again, going back to the concept of layered analytics and how it all is integrated. Like Splunk's good to start, but at some point, when it gets to resolution, you have to go to a very specific data set.
So it's not layered analytics, it's management.
It's
And
infrastructure analytics.
that's the value proposition. Well, all that stuff doesn't matter, because what matters is the result. The result is that you can proactively take action on infrastructure before a problem arises. Right. That's valuable. Simply another tool that monitors and sets off a pager isn't.
or even, a practical problem is that a lot of times, when we get to the troubleshooting part, the issue is that some weird configuration has reached this maximum, and trying to figure out that thing versus, a spindle went out, or I/O is.
But that's into the operations domain.
Right.
What I was hearing was they're kind of going up the stack, right, up that value chain. But that's not the case. What I'm hearing from your clarification is you're more in that infrastructure management piece, right?
It is infrastructure, and putting the infrastructure pieces together in context
I get that.
of, yeah.
I get that.
Cool.